Let's go into a little bit more detail with everything what we can do with metallic shaders. Because to create various versions, it's really easy to do when you know the building blocks, and they're so similar anyway. So we have here a scene, just only the basic chrome material. And I wanted to, before we continue, go over this make single fake user again. We want to add an anodized material. Okay, so let's click copy, and then this we call anodized aluminum. Okay, so when I go to here, you see that chrome now has a 0. When I close Blender, then this material, because it has no user, will be discarded. I could also purge everything that has no user. So that is why I click this. You see then, no anodized aluminum is not being used, it has a 0. I click then that one. Both actually have an F, but it also means it doesn't matter. It can be used, or it will be it will have its fake user. So this way these materials stay inside the file all the time. So Chrome is good. Now was the easy one. Let's go to anodized aluminum. And before we do this, let's do a Google search again. This is one of the biggest tips I can give you. Is crucial to do. It helps you to understand how everything looks. Look at the surface, the bump, the scratch, etc. Here we have some parts. Now it's also, is it cast? Is it polished and then anodized? Is it cast and anodized? So what are the surface properties? This is something we need to identify honestly before we really go into sketching creating the materials, etc. Because otherwise, maybe luckily we hit something, or we just move sliders and try to find something and we don't like it, and then we are getting frustrated because we're kind of like flying a plane blind. Okay, so we want to turn this into anodized aluminum. A nice, so should we use an orange color maybe? Yeah, there's an orange. Okay, good. Roughness we can really pump up. Then now we can see this creates kind of like this look. Okay, particularly here, the reflectivity is really nice and rough, or on those parts. And when we zoom in a little bit more, yeah, so the reflectivity is not as sharp and really blurry, giving us this matte look, but this is actually too perfect. Now, this is actually a surface that is super smooth, and this roughness slider is a help to simulate really, like, if you want to say that, on a microscope level surface imperfections that would blur, or not blur, would roughen up the surface, so we don't get a clear reflection, but a kind of roughed up, aka blurry reflection. Now we want to have more detail in there. And you see here, there's a little bit of a grain. This is more probably a saw or brush result, so we don't focus on that. We just and this is all gray. We just focus on the noise stuff. Okay, nice. Now it looks like a noise texture. So Shift A, input texture coordinate, Shift A, texture noise, object to there. We definitely know probably around 1000 is something that we need. We can do a quick check. Nope, too small. I mean, too big. Close. Okay, so that grain seems to look good. Be very careful now when you zoom in a lot and when you zoom out. the scale we set up here ideally should be in sync with a real world object we could list ideally, no? Also, one thing to keep in mind, our display has a certain resolution. If you have a retina display, then you can see details even sharper. This is a normal display. What I'm trying to say is some of the values that I type in, you might not at one point see a final result because it can't be shown anymore. It's there, but we can't see it. Okay, so let's say this graininess is good. We can put this into the color, so we see something like this. No, not too bad. So this is kind of like a visual trick to show that there is something going on. This is actually a tick also too strong. So Shift A, converter color ramp, and there we are. Now we're trying to colorize this, and the black we will brighten up. There, maybe like this. So it's not so strong. So next thing we need to do, this is basically now a tip to colorize the look of the metal. Reflectivity we set, we defined an overall roughness, and now we have to help making the roughness look more three-dimensional by, you got it, a bump. There to there, definitely .001, and there. Okay, way too strong. Maybe a tick too small. Yeah, better. So we're hitting kind of like here a little bit of a limit in terms of how fine the surface has to be. Think about like when we sandblast, how fine the damages to the surface are. So this for example here maybe should be 8,000. Oh yeah, okay, now I see it gets finer. What about we make this 20,000? Okay, yeah. Or what about we make this 60,000? Yeah. Now maybe we increase this a little bit. Good. So when we zoom out now, we don't really see much because that detail is just so fine, it can't really display. When we zoom in, we can see this more. So just, I'm showing this on purpose so you kind of like can get a feeling for the scale. But I think, while not perfect, this, however, starts to describe actually the characteristics of an aluminum body, or not aluminum, a sandblasted aluminum surface that, for example, can be anodized pretty easily. There we can add this color to it so it's more homogeneous. Also, if we want this to be more colored, if we, instead of making like a gray aluminum with kind of like the sandblasted texture on it, so this would be more for my color idea. Sorry, for my grayscale. If I now want to have a color version, color mix RGB, drag this one in, drag this one in. This goes into there, this goes to there. The result will be at first the same, because one color I have to make darker. Let's actually turn this to 0. There, okay, now we can see actually where this, that one color is. There you see a little bit of a structure. So I'm using the noise black and white pattern to generate kind of like a duotone image, and that will be displayed there. And then the grayscale will use or feed the bump mapping. Here the value is back, There we are. We zoom out. There we have it. Beautiful. So when we zoom in, clearly we can see this is wrong. But again, we try to simplify. Not simplify now. No, let's say it this way. We try to create via abstractions illusions of real-world materials. We just have to get it close. We can't really get it 100% right. Not with three-dimensional materials anyway. Good. So this is everything for how to make anodized aluminum. Not whoops. There. And then in the other video, I can show you then how we can make galvanized steel.